lesson 6.6, trapezoids and kites. Do you remember the Venn diagram that we looked at the other day? And do you remember where the trapezoids and kites were located on the Venn diagram? It was separate from everything else, right? It was still in the quadrilateral box, but it was not inside the circle of the parallelogram or whatever it was we had. I think it was a circle or an oval. Okay, so what makes it different from the parallelogram is that you only have one pair of parallel sides. You cannot have two. Once you have two pairs of parallel sides, this is no longer a trapezoid. Because once this turns and becomes parallel, you can tell it wouldn't look like a trapezoid anymore. And that's why it says exactly one. No more, no less. Exactly one pair of parallel sides. The two sides that are parallel are your bases. The two sides that are not parallel are your legs. The legs and the bases form base angles. And the only thing that we really know about just a typical trapezoid is that consecutive, not really consecutive angles, but one of the base angles is supplementary to the base angle it's across from, not the base angle that makes the pair. So this angle and this angle would add up to 180 because they're same side interior. There are two parallel lines cut by transversal, same side interior angles would add up to 180. And then these two angles add up to 180. But there's no relationship with these two angles or these two angles, except for that they're the base angles. This is a pair of base angles, this is a pair of base angles. Not sure what happened there. All right, so then we have an isosceles trapezoid, and that's a little bit different. That means the two legs are congruent, and when the two legs are congruent, you still have these angles that are supplementary, but when the base angles are congruent, not the base angles, the legs are congruent, the base angles are congruent. So now those are congruent to each other, and these are congruent to each other. These two still add up to 180. These two still add up to 180, but now we have congruent base angles, but only when it's an isosceles trapezoid. So, using that information, we can find the measures of the other angles in this trapezoid. So if the measure of angle S is 75 degrees, and this is an isosceles trapezoid, we know that the measure of angle R is, what do you think? We have congruent legs because it's an isosceles trapezoid. So what do we know about these two angles? Are they supplementary or congruent? Congruent. So that would be 75 degrees. These two, you've got parallel lines cut by transversal, same side interior, are supplementary, right? So those two add up to 180. So the measure of angle U is equal to 105, and the measure of angle T is congruent to angle U, and also is equal to 105. Then we have an isosceles triangle, and if you put a parallel line in that triangle, make it parallel to one of the sides of the triangle, you have an isosceles trapezoid. So AB is congruent to AC since it is an isosceles triangle, but DB is also congruent to EC. If we know that the vertex angle is 32 degrees, and we're trying to find X and Y, let's first look at just the triangle. Because this is an isosceles triangle, we know the two base angles are the same measure. So I could put Y in both places. That will help me set up my equation. 32 plus Y plus Y. Now this is just looking at the angles in the triangle. They should equal 180 because the sum of the interior angles of a triangle is 180. So that would be 32 plus 2Y is equal to 180. We'll subtract 32 from both sides and get 148. We'll divide by 2 and get 74. So Y is 74. And since this is a trapezoid, an isosceles trapezoid, or just a trapezoid, we know that x and y, those angles are same side interior, they add up to 180. So x is equal to, we're going to take 180 and subtract 74 from it. And get, what, 106? So y is 74 and x is 106. Does that make sense? That one was a little more complicated than the others, right? Because you have a triangle and a trapezoid. Then you have a mid-segment. We talked about a mid-segment of a triangle. A mid-segment of a trapezoid is very similar to the mid-segment of a triangle. The length of the mid-segment is the average of the lengths of the two bases. So, in other words, if y, let's say, is 10 and z is 16, then this would be 13? Would 13 be the midpoint, the middle number between 10 and 16? It would, wouldn't it? Okay. So what if we have how do you find the average of two numbers? Let's say this is 7 and this is 17. How do you find the average? How do you find that middle number? Wouldn't you say 7 plus 17 divided by 2 is equal to 12? So this will be 12. To find the average, you add the average of two numbers, you add the two numbers together and divide by 2. So what we did is, or what we're saying here is that x, the mid-segment, is equal to y plus z divided by 2. And we're going to use that idea on this next problem. We have 6x minus 12 for wz. Well, that's not going to be as easy as finding the midpoint or the average of two numbers. You've got an expression for wz, you have an expression for tw, so we'll have to set up an equation. So we know to find tu, we have to set it equal to something. It is equal to wz plus xy divided by 2. Segment wz plus segment xy divided by 2. So I'm going to take my expressions and plug into that. So tu is 2x plus 10. Wz is 6x minus 12. Add that to 18 for xy. Put that over 2. So we want to simplify that. 2x plus 10 is equal to 6x plus 6 over 2. I just put together the negative 12 and the positive 18. Next, we want to get rid of 2 in this denominator, so we can multiply both sides by 2. When I multiply this side by 2, it'll just cancel, and when I multiply this side by 2, I actually have to put it in parentheses because I'm multiplying the whole thing. I'm doing that over here too, so I could show it that way. So when I multiply this by 2, I get 4x plus 20 equals 6x plus 6. I'll pause there for a minute to make sure you understand what's going on this particular part. I multiply both sides by 2 to get rid of the fraction. And when I multiply the right-hand side by 2, it just cancels. When I multiply the left-hand side by 2, I have to distribute. So when I distribute, I get 4x plus 20. And on the right-hand side, the 2's cancel, so I'm left with 6x plus 6. Now I have an equation that looks a little more familiar, right? A little bit easier to work. Subtract 4x from both sides. 6, but subtract 6 from both sides. You get 14 is equal to 2x. Divide both sides by 2. X is equal to 7. But that's not my answer. It will help me get my answer. The question is or not the question, but the directions say to find TU. Well, TU is equal to 2 times x, and x is 7. We know now. So 2 times 7 plus 10. And the answer is 24. TU is 24. Let's check our work. If I plug in 7 here, I get 24. If I plug 7 in here, I get 6 times 7 is 42 minus 12 is 30. Is 24 the average of 30 and 18? Is it the midpoint? Is that halfway between? If I take 18 and I take 30 and I'll find the midpoint, would it be 24? It would be. Any questions about that? All right, a kite. It's a quadrilateral with 2 pairs of consecutive sides congruent and no opposite sides congruent. So that rules out a parallelogram. If the opposite sides cannot be congruent, it is no longer a parallelogram. But consecutive sides can be congruent. So we have a kite. So that means that 2 sides that are congruent to each other are longer than the 2 other sides that are congruent to each other. And if you connect the diagonals, not connect them, but draw the diagonals, you've got a cross. So it does share a property that a rhombus has, and that is that the diagonals form a 90-degree angle in a kite. And if you've ever flown a kite, if you've ever put together a kite, you can imagine those the sticks that you stick in there to make that cross. You probably would imagine that that is perpendicular. Okay. So here's something else that happens. These two are congruent to each other. They're bisected. And these two are bisected. This is not bisected, this is not bisected, but because we have an isosceles triangle, those angles are congruent to each other, and these angles, you don't have to memorize that, you can figure it out when you work a problem. Those 2 angles are congruent to each other. All right. So if we have a problem, we're trying to find the angle measures. Well, we know the measure of angle 1 is 90 because we said the diagonals form a 90-degree angle. But what about the measure of angle 2? Well, if this is 40, all 4 of these are 90. You can say that's 40, that's 90. If I find this angle, these 2 angles are congruent to each other. If I can find this angle, then I have the measure of angle 2. So if this is 40, this is 90, 40 plus 90 plus something is equal to 180. And that something would be 50. And if this angle is 50, this angle is 50. So the measure of angle 2 is equal to 50 degrees. And it will not let me write. For some reason, the computer froze on me again. So anyway, the measure of angle 2 is 50 degrees.